Let me go back to our TP. So this is how the reporting is expected. For instance, the first year will show the KMO test and Bartlett test value, and this all and we'll add a eigenvalue, EV and alpha. And here we'll keep a commonalities. So this all the things can be obtained in single page. Then that makes a lot of meaning for people who are reading the report also. Eigenvalue, then here TVE, then alpha stands for Cronbach alpha. Then here we can have a commonalities. Just let me type COMM, commonalities. Here one challenging with the outcome here is the commonalities here arranged in as per the data are entered into EFA model. Like A1, A2, it is in order. But when you see these things here, it is as per the sorted, because we sorted items as per the descending order. Now to match this, a simple way here is we can use some VLOOKUP and we can do that also. So let us show how to do that. Equal to VLOOKUP, lookup value. So the lookup value come from, this is a lookup value, comma, and we are looking from this table of array, from this table, and we need a commonalities from the third column. So what we'll do here, just put 3 for third, and it is a exact match. So we'll say false, close the bracket, enter. So before we copy the same formula for following cells, let us freeze the cell by pressing F4 twice. Here we don't want F4, only 4. Enter and select all the column and say Control D to get the output. Right? So now this is how it looked like. So we got all the commonalities in our side. So in the same way, we can see these commonalities I can reduce into 2 decimal. So at last the output has to show this rotate component matrix. Here we have to make the change the name, what we did earlier. We can do the same thing also because there is no change in the structure. So we can copy paste these things and we can paste it here. Fine. So now we got the name of each factor and we come to know which item belongs to which factor, and commonalities is given here, and coming down eigenvalue. So eigenvalue can taken from another table of SPSS. So the eigenvalue comes under total variance explained. So we can type it manually also, or we can do it just, we can double click in SPSS and select this, right click and copy and come back to Excel. So we can just paste it and copy this and we can transpose this also. So now we got eigenvalue. In the same way we can copy the, what we do. In the same way we can copy with total variance explained also. Copy this, Control C, copy this, and we can transpose this also. So we got the eigenvalue. Sorry, we got TVE. So we got both TVE and eigenvalue. Cronbach alpha has to be calculated. As of now here, if you just see that we got all the output which is required for the analysis, which include here. Okay, when we are reporting for EFA, we should report all these things. One is can mention about KMO and Bartlett test value. Then rotate component matrix, factor loadings of each factor. This can be removed because of duplication can be removed. Then we fetch a commonalities by just using some VLOOKUP in Excel. Commonalities got fetched. Then we copied figure of eigenvalue pasted here and TB pasted. At last we have to find out Cronbach alpha. Now coming back to SPSS now. So we got all the expected outcome. Now how do we calculate a Cronbach alpha? So one thing is, first we should understand which all the items belongs to dimension 1. So when you see these all the items, so we should make a note a name of this. What is the variable name? So the variable name shows such as we can say, let me show for 1 or 2 things, then we can do further. Here you can say A17 A11, A23, A29, A80. So this all belongs to one dimension. So we have to check the Cronbach alpha. So how do you check Cronbach alpha in SPSS? Go to Analyze, enable to identify scale and reliability test. So we should note it down first A17, A11, A23. So let me just go to A11, then A17, then A23, then 29 and 80. 29 and 80. So we selected all the items belongs to dimension 1 and you can see by default alpha is there and say OK. So the output shows like this 0.878. So as we discussed a Cronbach alpha should be more than zero point 0.7 and we are getting 0.878. So it seems to be quite good for us. So we can come down here and we can say Cronbach alpha is first dimension or first factor 0.878. In a similar occasion, let us try for one more dimension. Okay, we have to do it for all, but in demo, because of time constraints, I'll show for few dimension. Off the line, while doing the assignment, you can try out this. So let us take the financial part, financial dimension, which is say this is all the financial dimension or monetary dimension. So here we have to take A12, A6, then A24, A30. So go back to SPSS, analyze, scale, reliability analysis. Let us reset the thing and we'll choose a variable whichever you want. One is A6, then A12, then A24 and A30. So we got all these items which come from here. You can see all the 4 items got chosen. Once we chosen this 4 item, you can say OK. So it comes under financial and we have to type here as 0.823. So this is how the reporting for EFA has to be done. When you're showing the EFA table in any publication, we have to ensure that first it has factor loadings and commonalities and eigenvalue and TV, then alpha. So this all put together what we can call as the output for EFA. The output for EFA. So I hope you can able to assimilate the demonstration on EFA.